I will just use this, but okay, so I'm gonna write the value again. We will gonna use the 8 bits again. So 128 64 32 and then 16 8 4 2 1. Okay, so this first slot per here, so that is 1 1 0 0 1 1 1 1. Okay, so what I'm gonna do is add this ones. I'm gonna add them, add each one. So value of this binary in decimal is what do you call this, 128 plus 64, that is 192. Okay, so this is 192 plus 8. Okay, plus 8, 200. Okay, so 200 plus 4 plus 2 and 1, that is 207. 207, right? Yeah, 207. 207. Next, this one. So the value of this is 4 6 7. The value of this is 7. So I'm gonna write it down as well. So that is 0 0 0 0 0 and then 1 1 1. So the value of this is 4 plus 2 plus 1 is 7. Okay, next we go here, this lot. So that is 0 0 0 and then 0 and then okay, so where am I? So 4 3. Oh, I'm lost, sorry. So 1 2 3, so only 3 and then 1, sorry, then 1 again and then 0 1 0. Okay, so 16 plus 8 24 plus 2, that is 24. 16 plus 8 24 plus 1, that is 25. Okay, next way we get this one, this left. So that is 1 0 1 and the rest is 0 0 0 0 0. So that is 128 plus 32, that is 160. Okay, so the answer for this is 270, say that 7 dot 25 dot 16. Okay, so this will be the answer for number 2 question. Okay, so it's the okay, so number 3 question. So number 3 question, that will be, we will, what is the okay, so I'm gonna use a scratch paper again. Let's solve this problem. So number 3, network address 192.168.1.1. Subnet mask is 255.255.255.8. I think it's quite I think this is a 0. I'm not sure, but I think there's no letter. There must be no letter in IPv4 subnet mask. So I think this is just an error. So that is 255, subnet mask 255.255.255.0, I think. Okay, so let me know if it's wrong. Okay, so letter A is, what is the network address in binary? So network address in binary is, yeah, I think we solved this before. So the network address in binary, oh, so this is a network address and not an IP address. So what is the IP? Okay, so we answered this already before. So where is it? Yeah, what is the network address in binary? So as you can see, it's same as before. So I will gonna use the answer, because the binary answer for that is 1 1 0 0. Okay, 4 1 2 3 4. Okay, so 1 2 3 4 5 6 1 2 3 4 5 6 7 8. Okay, so this is 192, and then 168, that is 1 0 1 0 1, then 0 0 0. Okay, next is 1 1, so that is 7 zeros and 1. So 0 2 3 4 5 6 7 8. Okay, so this is the value of 1. Okay, next is 0 0 0 1 2 3 4 5 6 7 and 8. Okay, so while okay, so that is the value of that. Okay, letter B question. What is the subnet mask in binary? So in the binary value of the subnet mask, this one 255.255.255 is this one. Okay, so I'm gonna write again. So that is 255.255.255.0. Because it's letter A, so I am not sure, but I'm gonna write 0. Okay, so okay, so the value of this is, let's try to 128, and we're gonna use the bit value again. This one, 128, 64, 32, 16, and then 16, and then 8, 4, 2, 1. Okay, so this one is still the record. So what, how to explain it? This value, once we add them up, so for example, I will 128, okay, plus 64, that is 192, right? And then 192 plus 32 is equals to 224. So 224 plus 16, that is 240. Okay, so I'll just put a comma here. Okay, so and then this side, 240 plus 8, that is 248, plus 4, 252, plus 2, that is 254. I lost space. Then 251 plus 1, that is 255. Okay, so the value of this subnet mask will be, since we use all of these bits, so it will be 1 1 1 1 1 1 1 1. Okay, so the value of this is in binary will be 1 1 2 3. So 8 pieces of 1. Okay, then 1 1 1 1 1 2 3 4 5 6 7 8. 8 pieces of 1. There's 255.255.255.0. So 1 2 3 4 5 6 7 8. Next, so 0, let's say it's 0, so it will be 1 2 3 4 5 6 7 8. 8 pieces of 0. So this is the binary value of subnet mask. Okay, so what is the prefix length? So the prefix length so this is the long format in binary. So it will be 8. So each slot of this is 8 bits as before. So the length of this is 8, since it's 255, 8, 16, 24. The value of this is /24. Okay, so next question, letter E. In the network address, so 192.168.1.1, the underline the network portion and the encircle the host portion. Okay, so as he mentioned, it's a network address, so it's quite confusing now, because it says a network address and not an IP address. So this is a single network address. So if this is a network address, then the subnet mask must be also all 255 because it's a network address. So this is not a network address, then it's, I'm not sure. So in network address, underline, so because as you know, I'm gonna explain. In networking, there is an IP address, network address, and broadcast address. When we say network address, okay, I can compare the IP address to my, let's say, house address. Okay, and network address as my street address. And later I'm gonna explain what this. So once I said okay, let's have an example. My address in Philippines, it's 33 Don Juan Street. Okay. Next, my friend address in Philippines, he's my neighbor, and his address is 35 Don Juan Street. And my other friend, he lives in the little bit far, but we live in the same street. His address is number 40 Don Juan Street. Now, when we say it's IP address, it's like the house address. Okay, so the IP address is like my house address. So this is my house address. This is my friend's house address, and this is my other friend's IP address or house address, and we live in the same street, so that is the network address. So Don Juan Street, this is our network address. So that is our network address. And when we say broadcast address, it's the, let's say we live in Mambugan City, and you can say, yeah, it's like this, we all live here. Broadcast or barangay address, right? So that is what IP address, network address is, and broadcast address. So this is my house address, my friend's house address, and this one, this is our street address. So we all live in this street. So it's like this. This is my house, and then this street, this is my friend's house, this is my other friend's house, and we live in this street. Say we live here in the street. Okay, so that is IP address and network addresses. So it's quite confusing when you check. So if this is a network address, and because it's with this error, it was letter A. I don't know why it's letter A. If it's 0, then this is not a network address. This is supposed to be an IP address, because okay, so a little confusing. Anyway, maybe so underline the network portion and the host portion. So I'm gonna just answer this here. Because I'm depending on this subnet mask, so I can tell what is the network address and the host address. So, and it says here it's a network address, so we can be okay. Anyway, maybe it's an IP address. I'm confused. I'm gonna underline network portion, because if it's whole a network, single network, okay, then if it's 255.255.255.0, if 0, because it's letter A in the writing. So anyway, let me encircle this part. Maybe it's because our host, I write this /24, the prefix length. Okay, anyway, so this is my answer for letter E. So okay, so I think it's done. There is a question now. Okay, so question number 1: why do we need to convert the decimal value to binary value? Simply because the computers only understand binary values, and decimal values, it's for human, and binary values is for computer. So binary values is the only thing that the computer understand. So decimal value is for human reading only. Okay, so that is why we need to convert the decimal value to binary. Okay, and then number 2 question: why all computing devices have an IP address? Is it possible to have a similar IP address among end devices? Explain your answer. So first question is, why all computing devices have an IP address? So because we need the IP address of the computer so that we can communicate with other computer in same network or in different network. So we need the IP address so that our router knows where to send the packets, where to send the packets and the frames, everything. Okay, so we cannot communicate with anyone without an IP address. Okay, I'm gonna go this. Is it possible to have a similar IP address among end devices? Explain your answer. So I'm gonna explain. So the answer for that question is, it can be yes and no. So yes and no. So first, no. My answer will be yes and no. No. Okay, because yes, if yes, or no first. Okay, my answer no, because if let's say we have a computer here, and computer here, and let's say we have a router here, router R1, and let's say have 4 computers. Then we have an IP address of this IP, let's say 192.168.1.1, and then this PC also have an IP address of 192.1.1 192.161. That, sorry, I was sorry, 168. I mean, almost forgot. 168.1.1. So let's say, for example, this router here receive a packet for this PC. It must be in this PC. So let's say internet. Okay, so once this router receive that packet, he will be confused where to send that packet. Is it for this PC or this PC? Because you have the same IP address, so the router will be confused where to send that packet, and it will most of the time when you configure similar IP to another PC, it's gonna give you an IP conflict. Okay, so that is why no, we cannot have the same IP address with the same network. Okay, and if my answer is yes, for my yes answer, okay, you can have an IP address. You can have the same IP address, but you must be in a different network. Say, for example, this PC again here have 192.168.1.1 IP address, and then you are connected to this router here, and then there is another router here in a different network. You are connected, and then this PC here, and then this PC also have a IP address of 192.168.1.1. then you can use the same IP address because you are in a different network. So the router will not gonna be confused, because our router, when they are communicating, they are encapsulating every packet. So there is first there is a network layer encapsulation, that is destination IP. I mean, first is source IP, then destination IP, then it will go to layer 2 for the switches, that is for the MAC address, MAC as source. So for no answer, okay, so if you are in the same network, if you have the same IP address, and so the destination of the packet will be lost because you have two same IP address. But unlike with this part, if you have the same IP address but you are in a different network, there will be no problem because the router can handle where the packet will go. Okay, so if it's for this router 1, or it will be for this router 2. I think, yeah. So that will be my answer for question number 2. So it can be yes or yes and no, because yeah, we can have No, because we cannot have a same IP address in the same network. And yes, if we can have the same IP address, but we must be in the different network address. Okay. So question number 3. What is the importance of the subnet mask? So the importance of IP mask, subnet mask. Okay. Oh, I'm going gonna use another scratch paper. So for my question number 3, this will be my answer. What is the importance of the subnet mask? So the importance of the subnet mask is I forgot. Subnet mask is the pointers of network pointers. Yes, network pointers. What do I mean by network pointers? Because our computers, they only understand binary values, right? So let's say, for example, this is the 192, and say it's this one. Okay, 1 2 3 4 5 6 7 8, so one more 0, and then this is the binary value of 192.168.1.1. Okay, so let's say 101.0.1.0.1.2.3.4.5.6.7.1. Okay, same thing, 1 2 3 4 5 6 7 8. Okay, so what do I mean by network pointers? So the problem is in the computer, as you can see, there is a dot in here, but our computer, they don't see this dot because it is an ASCII character, and it's not they don't see this dot. Where is this? They only understand this is a straight 100.111. So they are confused where is the network address or network portion is. So what is the subnet mask do? He is pointing the what are the network address. So in this scenario, we have the 192.168.1.1, and then subnet mask is /24. Okay, so what the subnet mask do is he is telling the computer or the router that this is a network address, this is a network, this is a network. So network, and then network address. So this part here is the network address, and then this will be the host. So there will be no pointing here because it's /24. So until this part only, this is the host part only, the network portion only. Okay, so, and this is the network portion, and then this is the host or for the usable host part. So that is the importance of the subnet mask. It is pointing the network pointer, or it is by the subnetting, it is telling the computer what is the subnet mask. So that is the importance of subnet mask, it is guiding where what is the net what is the network address, and what. So whenever this not point anything here, just like this part, it's a host. Okay, so that is the importance of subnet mask. Next. Okay, so what can you conclude with this activity? So with this activity, I learned how to do the subnetting and how to solve the binary values, how to convert the binary values to decimal, and decimal to binary, and what is the use of the IP addresses, why do we use this, the network part. So that's it. So that is my answers. So to this activity, any question? So yeah, that's it. There's no more questions.